Hi, everyone. First of all, I want to thank all of the organizers of this event. What you've put together is really, really exciting and engaging. Also want to thank Mr. Chung and the rest of the HDAC team. You guys have been wonderful partners to us, and look forward to Nicola's presentation next. I've been obsessed with technology since I was about 10 years old. I started programming on an Amiga computer. A lot of you probably don't know what an Amiga is. It was actually a pretty popular operating system in England. And as a result, I became a computer scientist, got my master's at Carnegie Mellon, and then went to Wall Street for a while, but actually have been in the decentralized movement for quite a while. I first started in 2002 when I was an open source contributor to the BitTorrent project. And I've been an open advocate for open source and decentralized technologies. What I'm going to talk about today, though, is how we remove the barriers to mainstream adoption. First, I'll lay out some context, and then we'll talk a few specifics. But I think to start off, I'd like to talk about Arthur C. Clarke's 3 rules, because I think they're very germane to where we are as an industry. Oh, great. Just wanted to make sure we had the Korean version up as well. The first law of Arthur C. Clarke is that when a distinguished professor tells you that something is possible, he's almost certainly right. But when he tells you something is impossible, he's almost certainly wrong. And this segs really well into Clarke's second law, which is we only know what the limits of possibility are if we go right up to where the impossible is. And I think this is where we are as an industry. We've gotten up to the second law, where we're trying to touch the impossible. Where we do need to get, though, is Arthur C. Clarke's third law. Any sufficiently advanced technology is indistinguishable from magic. Let me give you an example about how that might look. Hands up, how many of you saw the initial launch video for the iPhone by Steve Jobs? Quite a few. So one of the most interesting things that happened there was he took out the phone, loaded up maps, turned it to the side, the entire map changed its orientation, and then he pinched the screen and the map got bigger. And everyone in the audience said, wow, because they had never seen anything like that. But if you actually think about it, it seemed like magic, but all those technologies have existed for a while. Gyroscopes are why it was able to measure the rotation. Multi-touch had existed for a while, and all the radio and other mechanics had already existed. But a magical experience was created because a few great components were put together. And there have been other magical experiences created. Uber changed everything. It connected you to your destination without a taxi. Airbnb changed everything. It connected you to a room without a hotel. Etsy changed everything by connecting producers and customers without a storefront. And all of these systems created a trusted network of connected people. I think blockchain has the potential to do so much more because in addition to transferring information, we can now also transfer value. Bear in mind, we're only at the beginning of where this industry is. There's about, $25 billion worth of value in smart contracting platforms. Some of you will disagree with this number based on circulating or non-circulating supply, but I just took this off of CoinMarketCap. And why I think this is important context is building momentum towards the adoption breakthrough takes time. It took Amazon 9 years to get 1 million developer accounts onto AWS. It took Apple 5 years to get 1 million apps on their App Store. And there are examples like this at Microsoft, Google, etc. So with that in mind, and knowing it will take time, how do we make blockchain feel less like technology and more like magic? I think it really comes down to 3 things. First, we have to move away from proprietary programming languages and proprietary standards to much more open standards and multiple programming languages. 2, we have to figure out a way to go away from price unpredictability over to a pricing system that makes sense for the average business. And finally, we have to solve the upgrade problem we have within blockchains. So let's talk about each one of these, but first, this is actually fully consistent with what entrepreneurs and enterprises are telling us. PwC does an annual poll asking people why they're not adopting blockchain. The number one reason really is cost and the unpredictability of those underlying costs. The second thing is they don't know where to start because the underlying technologies aren't technologies they've already been exposed to. And then the lack of governance and unpredictability of upgrade paths is the third reason. And then after that, there's all sorts of reasons. People don't see the value, the C-suite executives don't care about it, there's an uncertain regulatory environment. All those things are not under our control. But the top three reasons are completely under our control. And as an industry, we could fix the top three reasons why blockchains are not being adopted. Let's talk about the first one, open programming languages and open standards. Solidity is the most widely used smart contracting platform on Earth. It was a massive innovation. It's the reason why we're all here. But if we put it in context, there's probably 10, maybe 20,000 Solidity developers tops. There are 26 to 27 million developers total. And if you look at polls done by Stack Overflow, asking people for approval ratings of different programming systems, it's pretty clear. Consistently Rust, followed closely by Python, TypeScript, etc., is the most preferred programming language. So really, we need to create systems that talk to everyone. Every developer should feel like they're being welcomed to build on a blockchain. One of the technologies that enables that, for example, is WebAssembly. You can input in Rust, Python, Go, pretty much any programming language. And this really opens the world up to developers in general and not just blockchain developers. It's kind of like what's happening in this room, if you think about it. I'm talking to you in English. I don't speak Korean, which is probably obvious. But I'm able to converse with those of you who only understand Korean via a translation up here on my left, as well as the translators in the back. This is a beautiful thing. We're able to communicate with each other even though we don't know the same programming language. And I think blockchains need to adopt those principles as well. This would break the first wall. So let's talk about the second wall. The way pricing works in the blockchain industry is actually a little strange when you think about it. AWS, which is the most widely used cloud computing service, reduced price 46 or 47 times in the last decade. So as the system grew, as more people were using it, the benefits of that scale passed on to the end users. With blockchains, quite the opposite has happened. As Bitcoin and Ethereum grew as networks, it actually started to cost more to use them. It's kind of the opposite of what should be happening if you think about it. Therefore, it's really, really important to try and fix this problem. People need price predictability. When people are running their businesses and running contracts on the blockchain is a significant part of that cost bar, they need to know how exactly pricing is going to run. Otherwise, they can't really run their business appropriately. So how do we do this? Unfortunately, this actually brings up more questions than anything else. Perhaps the best way to do it is to peg gas price to some sort of fiat pair. Who provides that data? Well, my suggestion would be, there's a lot of groundbreaking work being done by, in the decentralized Oracle space. Sergey just talked about Chainlink, who I think have some really great innovations. But that could be a potential data source to ensure that you have a trusted price feed. And then other questions come up. Which currency should it be? We use USD sort of as our lingua franca in the industry, but Korea is a dominant economy too. Should it be based off of the KRW? Do we use special drawing rights? These are all questions we wrestle with every day on the team, and we'd love to hear your thoughts. But in general, we believe this is a problem that needs to be fixed. Third, think about how many times the most widely used platforms out there have been upgraded. I've just given 3 examples here, Salesforce, Microsoft, and Linux. And these are full-fledged kernel-like upgrades. If you include every single feature that's added, every single language that's supported, these actually number in the thousands. If you remember, when I started this conversation, I was talking about how I started programming on an Amiga. I think the reason why Amiga as a operating system died is because they didn't really address the upgrade problem thoroughly. So history has shown that widely used platforms become widely used because people know that they will be upgraded. What enables inherent upgradability? So we looked at a bunch of technology platforms, and it really boils down to three core things. There's probably many more things we could list, but it comes down to three core things. The first one is abstraction. Abstraction means that one layer of the tech stack doesn't care about what's happening in another layer of the tech stack. I'm going to grossly oversimplify right now, but the internet sort of works like this. The network layer and the application layer are completely abstracted from each other. The network layer doesn't need to know what the application works like under the hood. It just needs to receive the right messages from it. And the application layer doesn't need to know how the network actually runs, it just needs to know how to access it. And CBC Casper as a consensus protocol is highly abstracted, which enables upgradability over time. The second thing is modularity. Different functionality in different parts of the system should be able to be upgraded separately without affecting one another. If you think about how Windows is designed, or Unix is probably an even better example, it's highly modular, which is why we've been able to upgrade Unix and Linux so many times. And finally, you need process control. Think about how your phone is upgraded or your Windows laptop is upgraded. You know that a notification is going to come up and you can just hit yes or no, and the upgrade applies automatically. However, full decentralization makes this kind of challenging. If you think about the systems we just talked about that are upgradable, they both have a centralized software writer and centralized instances that they can access. On the other hand, if you take the Bitcoin and Ethereum networks, the two most decentralized networks, ideally you want a decentralized software proposer, meaning anyone can propose an upgrade, and you also have highly decentralized instances. So what do we do? In my view, the ability to upgrade in protocol via smart contract would be game-changing. But it also brings up a litany of concerns. First of which is, what do we do about controversial and non-controversial upgrades? So let me give you a specific example here. A non-controversial upgrade would be one that merely increases performance and security. And if it does no other changes, most people would accept that and say this is a non-controversial upgrade. What could be a controversial upgrade? An upgrade that changes the mining reward would be a controversial upgrade. An upgrade that changes the decentralized nature of a system would likely be a controversial upgrade. The ability to delineate between these two and put together the appropriate governance processes would be really, really important. Because what if someone sneaks in a controversial upgrade with a non-controversial one? You will get better performance, but we will slash mining fees down to 1/10. That's a situation we don't want. What we can do is build the technology that would enable this, and hopefully, make sure that we can eventually come to a place where we solve the governance problem as well. But what this would allow you to do is it would allow apps to evolve alongside the businesses that depend on them. And I think that would be magical. So just a little bit of how we are approaching solving these problems. One, our system supports concurrent orchestration, which means processes that aren't dependent on each other can execute simultaneously, making it much more efficient. And then, of course, in subsequent releases, we will have sharding, which is proportioning the network, as well as heterogeneity via sidechains. And then we believe in embracing open architectures. Make sure that every developer is a blockchain developer. Sorry, just experiencing a slight delay with this. And then we think every day about how to future-proof our platform for business. Predictable transaction fees are extremely important to us, and we've put in a lot of mechanisms to ensure that our blockchain is upgradable ad infinitum. So just to close, I want to thank you all for listening, And I want to say, we're all in this together. We would love to hear your thoughts on all the things we talked about today. Hopefully this is helpful for all the projects out there. I think a rising tide lifts all ships. If you want to talk more to us about this, please join our Telegram group. You can do it right now with your phone if you take a picture of that QR code. We'd love to know what we're doing right. We'd love to know what we're doing wrong. We welcome all critique. And hopefully an engaged discussion will be great for the industry as a whole. So, we all have a lot of work to do, so let's start building. Thank you.
Thank you.